In Module 2, we talked about independent events. Now let's talk about independent random variables. So when are two random variables independent? If the knowledge of the value of one random variable tells you nothing about the value of the other random variable. So for example, pick a given year. Look at how many games Real Madrid soccer wins and the Dallas Cowboys football team win in a year. They happen to be the two most valuable franchises in sports. Well, I think those are independent random variables, because if Real Madrid has a really great year, I don't think it tells me anything about the Cowboys. And if the Cowboys have a great year, I don't think it tells me anything about Real Madrid. Now let's look at two random variables that are absolutely, positively not independent. Let's look at the return on Exxon stock in a year and Shell stock in a year. They're both oil companies. Okay, they're not independent. Why? Because if I told you Exxon did great, that means basically one main thing. Oil prices really were high. And that would mean that Shell would probably do great. So basically you can't say the returns on Exxon and Shell are not related, because the key determinant of those returns is simply the price of oil. Now, what if we have more than two random variables? Random variables x1, x2 through xn, how are they independent? If the knowledge of the values of any subset of the random variables tells you nothing about the value of the other random variables. For example, if x sub I is the pizza sold at a pizza shop during the ith day of the month, and we have x1, x2 through x30 in a 30-day month, say June, and we say they're independent, what that means is, if I told you the number of pizzas sold the first 10 days of the month, it tells you nothing about the number of pizzas that would be sold during the remaining days, 11 through 30 of the month. Now, a very important example of independence is what's called the efficient market hypothesis in finance. So suppose X sub I is the return on a given stock on the ith day of the year. The efficient market hypothesis says X sub I is independent of the previous days. In other words, if you know what happens to a stock on its returns on previous days, it gives you absolutely no information on how it's going to do today. There's a lot of debate on whether this is true or not, but Eugene Fama won the Nobel Prize for Finance for a lot of research showing the efficient market hypothesis is true, and Robert Shiller won the Nobel Prize for Finance for showing the efficient market hypothesis is false. So figure that out while you wait for the next video, which will discuss how to find the mean, standard deviation, and variance of random variables.